the variable m varies inversely as the fourth power of n. If k is the constant of variation, which equation represents the situation? Well, I'm going to move my iPad for a couple minutes here and just talk about, first of all, the formula for varies inversely. And the formula for varies inversely is x, y equals k. And it might be nice if you could see that. X, y equals k. The program probably did use D and N back in there. I don't know, but that's what I wrote down in my notes. So again, what this particular problem says is it says the variable m varies inversely as the fourth power of n. The variable m varies inversely as the fourth power n. So there's the fourth power. So if k is the constant of variation, which equation represents the situation? It is that second choice right there. Problem number 6, very, very similar. The pressure P with which the water passes through a pipe varies inversely. So as you're working through this unit, make sure you're looking for, does it say varies directly or does it say varies inversely? As the square of the pipe's radius are squared. If k is the constant of variation, which equation represents the situation? Well, again, I hope that you can eliminate 2 of these answers on there, because we have not seen anything with addition in either varies directly or inversely. But again, the pressure P with which the water passes through the pipe varies inversely as the square of the pipe's radius equals k. And it might be nice, square of the pipe's radius. There we go. And then if we go back and we look at this problem here, we can see our choice. So now that we've set up a couple of direct variation problems, let's go back and do a problem with the numbers in them. So, adjust this here. The square of z varies inversely as the square root of w. If z is 36, when w equals 16, what is the value of z when w is 81? So, we start off here, and it says that the square of z varies inversely as the square root of w, and that's going to equal k. So it says if z equals 36, so we have to square it, times when w is 16, we're going to get the constant of variation here. And don't be concerned that it's a big number, because when we type this in, 36 squared times the square root of 16 is 5,184. I took that away fast, sorry. I just typed that in. 5,184 equals our constant of variation. And now that we know that, then it says, what is the value of z when w equals 81? So we're still going back. We're going back into this formula of z squared w, but we can put in our value of k. That's going to be the 5,184. And then one more time it says, what is the value of z? So z squared, we don't know what that is, times the square root of w, but w is 81 now. If we take the square root of 81, it is 9. And then we want to solve this equation. Well, it's z squared times 9. We're going to divide both sides by 9. And we get z squared equals, well, 5,184 divided by 9 is 576. And when we solve something, we see z squared equals, well, the inverse operation of squaring is square rooting. So if we take the square root of 576, and by the way, you can use Desmos. If you take the square root of 576, we'll get our value of z, which is 24. And that was a choice on our answers.